evaluated at
0.
t, evaluated at 0, and you will subtract, and you will have the right-hand side. Now I will come into this thing and put the t in, and I will put the 0 in, and you will say I will pick up my function of t. Let's put a t in here. What do we get? 5t cubed over 3 plus e to the negative t. Subtract what? 5 times 0 cubed over 3 plus e to the negative 0 being what? 1. So we have here 5t cubed over 3 plus e to the negative t. What?
Minus 1.
Minus 1 is equal to v of t minus 7. So we have our velocity function. We will just take that constant to the other side, and you've got your velocity function. You can describe to your professor in physics the velocity at any time. Say, what is the time? 10. Put a 10 in there, you will get the velocity. What is the time? 11. Put 11 in there, you will get the velocity. Even though you were just given the acceleration function. There is your velocity function. And now the professor says, oh, very good. So you have a handle on the velocity. Can you get a handle on the position? Well, if I have the velocity function, I will need to undo the different derivative because velocity is the derivative of the position. If I want the position, I want to do the integration of the velocity. We'll do the same thing. Except we will use the velocity to get the position. The velocity being the derivative of the position will give us the position. Let's do it. And remember our initial condition is 0. Come in here, 0 on t, the integral of the velocity is the position t minus the position 0. So I will just need to integrate this, find out what it is when I put t and 0 in there, and I will have my position to a constant. Now in this case, now this is 0, so I'm sorry. Well, we have it exactly. What is v of x? Well, here it is. So we have to integrate this to get the position. And now it's a calculus 1 problem. As a matter of fact, if you had me as a calculus 1 professor, all of this would be calculus 1. Is that correct, Ms. Jasmina? So now we have to find the antiderivative. What is the antiderivative of 5 thirds x to the power 3?
5x is 1 5 minus e
Minus e to the minus x
plus
6x. You evaluate the t, and then you'll pick up your function of t. Evaluate it at 0, subtract, and you will get your function of time up to a constant, but that constant is 0, so we'll go to that. Now, there are other professors who do it another way. If you have another professor who does it that way, they actually tell you to find the constant. Good luck, do it that way if you wish. My point is just take the constant to the other side. integrate whatever this thing is. Take the constant to the side. Do the algebra. Because if you try to do it the other way, you have to solve the equation of C. Now, we have to do the calculations here. So you will take this antiderivative, evaluate it at t. Evaluate it at 0 and subtract. The position function. Plus 1. So there it is. Plus 1. That's the position function. This is not a concocted problem. Very often your professor from physics would have given you would know the acceleration function. How would a professor know the acceleration function but not the position function? Because they know about Newton's laws of physics. They say, all I see are the forces acting on the body. And the force produces acceleration. So they know how the force is causing the thing to accelerate. But they don't know what is the velocity and what is the position. But then they know some calculus. Hey, the derivative of the position is the velocity, and the derivative of the velocity is the acceleration, so if you integrate, you can pick them up. Now this is very important in any field that uses things that change with the time. Because often you know the law for the derivative, not the law of the actual function. Let's leave it at that. So here's this a simple one.